Welcome back to AIM Chemistry, Learn Chemistry with Dr. Poonam. In this video, we will start Unit 1, that is Quantitative Equilibria, where topic acids and base, and today we are going to focus on conjugate acid and base, which is an essential concept in understanding acid-base chemistry. So mainly we are going to cover first two objectives where we will understand and use term conjugate acid and conjugate base. In addition to it, we will define what does mean by conjugate acid base pair, and we will take some examples to identify such a pairs in reactions. In everyday life, we hear term acid and base. Since grade 8, we are studying what is meant by acid and what is meant by base. We know many examples. Even we know properties of acid and bases, that how on the basis of pH we find out this species is acid and this species is base. So students, but now we are in grade 12. So we are going to discuss and study more sophisticated and used definition of acid and base. Actually, the concept of acids and bases is explained by three important theories. The first one is Arrhenius theory. Students. Then second theory is Bronsted-Lowry theory, and third theory is the Lewis theory of acids and bases. So students, here our syllabus oriented theory is Bronsted-Lowry theory. There were some drawbacks of Arrhenius theory, that's why Bronsted and Lowry, they are two different scientists. In 1923, independently proposed a more general definition of acid and bases. So, according to them, with example, we will discuss that. So, according to them, they define acid and base like acid and base. So, according to Bronsted and Lowry, acid is a substance. Acid is a species. It can be molecule, it can be ion, that means it can be cation, it can be anion. But it must contain H+. This is a H+ containing species which is able to donate H+. So in a simple word student, acid according to Bronsted-Lowry concept, acid is that substance which can donate H+, or we can call it as a proton, H+, or we called it proton. Means proton donor is an acid. Now next to it, base. So according to Bronsted and Lowry, the base is a species which gains H+. Which gains H+ means hydrogen ion, that means it gains proton. So we can say like that, base is a substance student, base is a species, it can be also molecule, anion, cation. So base is a species which can accept proton, or we call it as H+. So that means that together the acid is defined as a which species which donate H+, and base is accept proton, that means H+. So student, when we combine together, definitely they will give some new concept. So let us take one example to understand this concept of acid and base. So if I take an example of HF, hydrofluoride acid. So if this is acid student, and we can see this is a H+ containing species. So it is available. So when H+ is available, so it is ready to donate that H+ with the release of F-. So acid is here, you can say that acid which donates H+ or proton. Now here if we take an example of base, if I take an example of ammonia, and when we add H+, so that time student, there is a formation of NH4 plus ion, that is ammonium ion. So means ammonia is a base and it can gain one proton and it can form ammonium ion. So we call this ammonia base. So this is a very simple concept students, where acid is a substance which donates proton and base is that substance which accept proton. So together, when we take them together, again we will take some few examples. Like if I take example of HCl, hydrochloric acid. So student, it contains H, so it will donate this H plus and with the release of Cl minus ion. If I take an example of H2SO4, so student, first we will release one H plus. So after taking out one H plus, there will be a 1 minus charge. So these are the examples of acids where there is a donation of proton from given acid. At the same time, if I take an example of one more example, we can take hydroxyl ion. Hydroxyl ion behaves like a base because it is able to take H plus. So it gains that H plus and form water molecule. So student, and mainly you need to consider this should be in a aqueous state. So acid is that substance which donates proton and base which accept proton. So this is the simple student definition of acid and base given by Bronsted and Lowery. Now after that, if they are forming something together, if acid is giving base and base is giving acid, so we have to give them a something name, and that will be conjugate acid base pair. Conjugate acid base pair. See, here I will take one simple example, HCl. As we know that HCl can donate H plus and it gives Cl minus. But student, the interesting fact is that if this is acid, that means when it is donating H plus, it is giving you base. Now student, the very simple thing, this chloride ion also able to gain H plus. It donate and this Cl minus gains H plus and it form HCl. That means there is a donation and gaining of H plus. So when acid donate H plus and the species form is called as conjugate base. Conjugate base. And that conjugate base is able to gain proton. So student, this is the concept of conjugate acid base. When acid is there, acid donate H plus and form conjugate base. Why we call it conjugate base? Because that base is again able to gain proton to get back that acid. See, if we take again one more example. So if we together we can discuss this example, how conjugate acid base formation is there. If we have an example of HCl plus we will take water molecule. It should be in aqueous state. This is water, means it is in liquid state. This reaction is in equilibrium, students. The arrow stands for equilibrium arrow. That means rate of forward reaction is equal to rate of backward reaction. So as we know that here HCl is acid, so it will donate proton. So donate H plus. So we can write here donate H plus, that's why I am putting here minus sign. So after donating proton, it will become, see, initially we have H2O, so it will become H3O plus, which is called hydronium ion. Hydronium ion. So now student, we can see that this HCl is donating proton to this water molecule. It is donating proton and that water molecule is accepting that proton, and that's why it is base. This H plus donates and this water molecule is accepting this, and this is the reason we called it base. And that water molecule after gaining that proton become hydronium ion. And this HCl, when it lost this H plus to water molecule, there is a formation of chloride ion. Now students, this is the acid and this is base. Now this acid gives you chloride ion, and if we see this chloride ion, if it gains H plus, surely it will form HCl. So that means that Cl minus is a conjugate base of acid HCl, because acid donates proton, base gains proton. Acid forms chloride ion. Chloride ion is also able to gain that proton. So that's why chloride ion is a conjugate base of hydrochloric acid. Now, this hydronium ion is able to lose one proton. It is able to lose one proton and it will give you water molecule. So if when there is a loss of one hydrogen ion, loss of one proton, it will gain and it will lose. So student, that time we can see like that hydronium ion is losing, that means it is conjugate acid. So in this way student, from, see, I will change pen to make it clear. So when acid is there, acid donates this proton to base, okay, and it forms hydronium ion. But at the same time, acid is giving base, and this pair, this is acid and this will be base because it is able to gain proton. We call that acid base conjugate pair. Next is, this is a base. Water is behaving like base here. So here student, after if you formation of hydronium ion is able to donate this H plus, and when it is able to donate this H plus, so it will be conjugate acid. So in this way there is a formation of conjugate acid and conjugate base from given an acid base, and this is the concept of conjugate acid pair. Thank you very much students for patient listening.